Hi, my name is Dan Surratt, and on behalf of Severard Associates, I proudly present to you One Vanderbilt. So One Vanderbilt is a state-of-the-art tower located in East Midtown in Manhattan. At 1,401 feet tall, it's the tallest building, tallest office building in Midtown. This is a photo looking east down 42nd Street, and One Vanderbilt is the big one in the middle. And you can see the Chrysler building just beyond it on the right side to the east. All right, here's a shot looking from 42nd Street toward the west. On the lower right is Grand Central Terminal, and our site is the entire block directly west across from Vanderbilt Avenue. Here's a shot looking south. So Grand Central is on the left, and One Vanderbilt's on the right. And part of the deal with the city in order to get approval for the development, there were transit improvements and connectivity created from Grand Central Terminal, subway, and commuter rails directly into the building within the lot of One Vanderbilt. In this shot, you can see the carved out geometry at the bottom of the building. This was in order to reveal the southwest corner of Grand Central. And that kind of carved out geometry necessitated column transfer so that we didn't have interior columns running up the tower. So you'll see later on in the presentation there are significant column transfers. And here's a shot looking straight up from Vanderbilt Avenue. All right, so it's a massive project, complex zoning approvals, multiple SDs, pre-construction coordination in BIM, including Tekla, every other kind of design software all brought into Navisworks and coordinated so that the vast majority of the kinks were worked out before there became problems in the field. Early permitting and fast-track construction as laid out in the AISC. Structural system and erection sequence. So you'll see that the building is basically core, about 30-inch thick concrete core is the gray, and the light blue perimeter is all structural steel, floor beam, slab on deck, and perimeter columns. There are no interior columns. So part of in order to fast track the erection sequence, we decided that we had room to put in a steel frame, a temporary steel frame that would allow the steel contractor to erect the floors ahead of the concrete contractor. So you'll see that the temporary frames went up about 12 floors ahead of where the concrete walls were poured. All right, here's a look at the typical lateral frame. Right, the center represents the shear walls represented by a brace frame of equivalent stiffness. There are transfer trusses. There are two at the bottom of the building at the 5th and the 12th floor, and then you have belt and hat outrigger trusses toward the top of the building to control the drift curve. So the idea is that the graphic on the right is the torso and the legs would represent the concrete core with the embedded steel. The arms represent the outrigger trusses, and the ski poles represent the perimeter columns engaged in the lateral system. All right, I'll take you quickly through the foundation so you can get a sense of the scale, and then I'll work my way up. So there were several buildings on the lot before the construction. Right, none of them had more than one basement. So in order to get down to the 4 basements necessary to connect into Grand Central, we needed to excavate 40 feet of rock. And once we got to the bottom, about the 3rd basement, sat the concrete core for the tower, for the mat foundation which supported the concrete core. All right, here's a peek inside the mat. The mat is from the top layer of steel to the bottom layer of steel is about 9 feet thick for reference. All right, here's a look at the concrete placement for the core foundation mat. It was over 4,000 cubic yards continuous in sub-freezing temperatures. It was the largest continuous concrete pour in the history of Manhattan. And you'll notice the dowels for the shear wall coming out of the mat. We had to set the first tier of steel columns directly between the rebar cages. All right, superstructure. We're getting to the good stuff. Came in at 26,000 tons of structural steel. That includes erection aids. All right, here's your first tier set between the rebar dowels for the core wall. Of course, all the anchor bolts were set in the mat placement, and of course, every single one of them moved along with every single dowel. So once they surveyed the location of the anchor bolts after the concrete hardened, we made whatever adjustments we needed to make so that the columns were set directly where they needed to be, and we didn't have to correct going up the building. We did all our correction at the starting point. All right, we'll just work our way up. It's coming out of the ground. It's coming out of the ground. You see all basically everything you're seeing in these pictures is going to be covered up in concrete later. These was just erection aids so that the perimeter could be erected up ahead of the concrete contractor. All right, here's connections for the outrigger trusses. You'll see that we used box sections, so made out of between 3-inch and 8-inch steel plate, all seam welded together because there were no rolled shapes that met the demands in some locations. You'll see basically a mix. Wherever we could use rolled shapes, we did, and where we couldn't, we went to boxes. And likewise, gusset plates up to 8-inch thick, and where the forces in multiple directions couldn't be resolved with laminated plate nodes, we used forgings. All right, column transfers. I mentioned that we have gravity column transfers at the 5th and the 12th floors. Here's a look at them being erected. So this is, you'd be looking at one of the corners of the 5th floor transfers being erected. That's a 10-foot deep plate girder on the flatbed, which also was part of a system where we couldn't get diagonals because of various MEP constraints. We were forced to use plate girders, and in this case it was 2 floors, so 2 plate girders directly on top of each other in order to get the stiffness that we needed to control the drift of the building. All right, here's a case of multiple beams coming, or multiple truss members coming together in one spot. Really thick gusset plates, and you can't really see it behind all this, all the things converging, but there's a forging in there to resolve all the forces in different directions. All right, here's just another closer look. You can see that we had shear studs welded to all the stuff that was embedded in the core, especially with the outriggers that was used to drag force from the steel members into the concrete in the final condition. All right, more pictures of outrigger trusses. All right, here's what we affectionately call the Dr. Seuss column. It's made up of a forging. Let's go back. You got a forging, you got box columns, you've got rolled shapes, and you've got a 12-inch rolled plate in there somewhere, all to make minor adjustments at I think this was at the 5th floor. All right, some more shots of the outrigger trusses going up. We had a 2-mast damper at the top of the building. That was to control the drift, or sorry, not to control the accelerations at the top of the building. Now we're up above the roof where it was all mechanical space, was all done with galvanized rolled tubes up to 22 inches by 22 inches. I know Atlas Tube has done a lot of articles and whatnot on this particular area of the building, so if you're interested, check them out. Here we're up above the Chrysler building. All right, and here's what we call the snorkel. All this bracing was exposed behind the glass, so it was architecturally sensitive. And here's your spire. The spire was made out of a 100% steel plate, around 2 inches thick. All those fins were, served the purpose either for the wind tunnel or for ice control. All right, and we're gonna watch it go up and up and up and up and up, all the way to the top of the building, to where the couple of guys from NYCC took a selfie at topping out. So we'd like to thank ownership. We'll roll through them. The design team, the contractor, Tishman, and especially the steel fabricator, banker, and the Erector NYC constructors. All right, and too many other people to name. We're eternally grateful, and especially AISC for their special consideration of this project. Thank you very much.